In a previous video, we discussed the transfer of energy between a system and its surroundings. When a chemical reaction takes place, it either needs to be provided with energy from the surroundings to fuel the reaction, an endothermic reaction, or it gives off energy to the surroundings, an exothermic reaction. There are two ways in which energy can be transferred between the system and the surroundings: heat and work. We'll focus on work in this video. When we talk about work in the context of chemistry, we are mainly interested in the work done by the compression or expansion of gases. Let's imagine that we have a container full of gas and the lid of this container is flexible and can either expand or compress. If we have a large pressure of gas in the container and a low pressure outside of the container, what do you think will happen? That's right, this gas will expand against the outside pressure, pushing the lid and making more space. What must be true about this process? Expansion of the gas. Imagine if you were in the container and pushing to get out. That costs energy. In order for a gas to expand, it will expend energy. So let's talk about a chemical reaction taking place in this container. Before the reaction starts, the inside and outside pressure are the same, but over the course of the reaction, gas is produced and the pressure inside starts to build. What must be true about this reaction? Since more gas is being produced in the reaction, the gas must expand as the reaction takes place, but this costs energy, so the system is losing energy, or W is less than zero. W is the energy change of the system due to work. We always denote the sign of the transfer of energy in terms of the system, so if the system is losing energy, the sign will be negative. To calculate the amount of work done by the gas expanding, we use this equation. Let's say that we increase the original volume occupied by our gas by 15 liters against an external pressure of 1.35 atmospheres. What is the work done by the gas? We said that the external pressure is 1.35 atmospheres, and so when the new gas is produced, it forces the gas to expand by 15 liters against this pressure. So we get that the work is equal to negative 20 liters times atmospheres. We'll once again note that the sign of the work is negative. For this reaction to happen, the system loses some energy as work because gas is being produced. Let's look at one more example. What do you predict to be true about the work associated with this reaction? Notice that the total moles of gas does not change in this reaction. If you started with 1 mole of nitrogen and 1 mole of oxygen, then you would make 2 moles of nitric oxide. That means that the number of moles of gas does not change. If the moles of gas don't change and the pressure and temperature don't change, then the volume will not change either. So that means that there's no work being done. Let's summarize. We just saw that when there is no change in the moles of gas in a reaction, the volume occupied by the gas will also not change. That means that there is no work being done. We also saw that when a gas is produced in a reaction, it must expand. When the volume of the gas increases, energy is lost by the system, and so work is negative. What would happen if a gas were consumed in a reaction? When a gas is consumed in a reaction, it must compress. This means that the volume occupied by the gas decreases, which is the opposite of what we saw for an expansion. So what does that mean about work? That's right. When a gas is compressed in a reaction, the system will gain energy and so work will be positive.